It is always useful when we organize the objects. For example, words in dictionary. Dictionary classifies all the words in alphabetical order so that it would be easy for the reader to find words easily. Similarly, books in the library are classified on the basis of their genre so that a reader who is looking for a book in kids section can easily find one. There are many known elements in the world such as gold, silver, iron, oxygen, carbon and iodine. To make systematic study of these elements, it was necessary to classify and organize these elements. In the history, scientists tried to classify these elements for systematic study. There were several attempts made to classify the elements known at that time. The first known classification was made on the basis of states of matter, like solid, liquid, and gas. But this classification was not very useful because some elements such as bromine and mercury are liquid at room temperature and solid in other cases. There was one more attempt to classify elements into metals and non-metals. This method is useful for some extent, as all the metals and all the non-metals can be distinguished by some characters. Like metals are good conductors and non-metals are non-conductors. But it is not satisfactory because even though sodium and iron are metals but have very distinctive features and cannot be grouped under the same category. Broadly classifying elements as metals and non-metals was okay, but this classification did not help scientists to make systematic study about all the elements. William Prout in the year 1815 suggested that atomic mass can be used as the basis for classification of elements. Atomic mass is the mass of an atom, which is usually addition of neutrons and protons in the atom of that element. First attempt of classification was made by Dobereiner. Dobereiner formed a group of 3 elements called triads having similar properties and arranged them in increasing order of their atomic masses. For example, he made group of chlorine, bromine and iodine. This group is an example of triads and Dobereiner arranged them in increasing order of their masses. Another such group was group of calcium, strontium and barium. The law of triads was also not helpful in classifying all the known elements because with this theory it was not possible to group all the elements known at that time. But this theory was little helpful for scientists who were trying to classify elements. It gave a clue to the scientists that elements can be tried to classify on the basis of their mass. Then many scientists tried to classify elements on the basis of their mass and tried to discover a pattern among elements which can be helpful in classifying elements. Following the clue given by Dobereiner, Newlands formed law of octaves. He grouped 7 elements instead of 3. Newlands arranged the elements known at that time in the increasing order of their atomic masses. He made group of 7 elements. He placed 8th element below the first element in the previous group. He found that when elements are arranged in the ascending order of their atomic masses, starting from any element, every 8th element is similar to the first in the chemical properties. That means starting from any one, the properties of every 8th element are repetitions of the properties of first element. It is like the musical notes. The word octaves is used in music. This is the reason for calling this method of classification as law of octaves. For example, consider these set of elements. These are all placed in ascending order of their masses. Start from element iodine. The eighth element, hydrogen, share same properties as iodine. Then next eighth element is fluorine. All these three elements share same properties. If you have started from the element lithium, eighth element will be sodium. It has to be placed below lithium. Lithium and sodium does share same chemical properties. Though Newlands prepared a table keeping every eighth element below the first in an attempt to classify the elements, it was not possible to extend this law after 17 elements. Law failed after grouping 17 elements. Newlands was actually ridiculed for comparing chemistry with music. However, Newland's contribution did not go in vain. He introduced the concept of periodic in classification of elements. He made important discovery that elements do have pattern and some repetitions when it comes to their chemical properties. According to Newland, repetition of properties occurred at every eighth element. This law of octaves was studied deeply by another scientist called Dmitri Mendeleev. He was convinced that elements can be classified on the basis of mass and there is a repetition of chemical properties after some interval. Newland stated every eighth element is a repetition. His interval was 8 elements, but Mendeleev extended this theory and told the interval may not be only 8, it could be 18 or 32. He stated the properties of elements repeat at regular intervals when arranged in the increasing order of their atomic mass. The periodicity is not regular at 8. It may be 8th, 18th or 32nd. Mendeleev modified Newland's law of octaves by replacing the word octaves by regular intervals. Mendeleev's periodic law is stated as the properties of elements are periodic functions of their atomic mass. The meaning is that the properties of elements repeat periodically at regular intervals when arranged in the increasing order of their atomic mass. Considering atomic mass of elements and considering the principle that after some interval chemical properties of elements tend to be same, Mendeleev constructed a table of elements. He arranged them in groups and columns. Elements having similar properties were kept in the same group. He could not make a perfect table with all known discovered elements. He left some vacant places in his table. He stated elements in those places are yet to be discovered. Mendeleev was able to predict the atomic mass and properties of elements of those vacant places even before their discovery. Periodic table of Mendeleev helped in discovery of new elements like germanium. Mendeleev's work can be regarded as very accurate in the absence of knowledge of electronic configuration of atoms. Once atoms were fully understood, it was easy for modern scientists to make classification of elements. Modern table is not very different from Mendeleev's periodic table. For your information, modern periodic table is not based on atomic mass, but it is based on atomic number. Atomic number is the number of protons in the atom. The modern periodic law, as stated by Moseley, is the properties of elements are periodic functions of their atomic number. Until now, you have studied several attempts made by scientists to classify elements for systematic study. You learnt initially elements were classified on the basis of their state and then by their nature. Attempts were made to group them depending on their masses. Finally, modern periodic table constructed on the basis of atomic number. We will study more about modern periodic table in this chapter.